Hello everyone, welcome to the tutorial of showing you how to create your local environment in the Windows to build the C++ Boots library. So first off, the C++ Boots library is a very powerful library. Uh, in matter of fact, it's a libraries set. Um, in my opinion, every serious C++ programmer should learn about this library. And in this tutorial, I will show you how to build a library such that it can be used in Visual Studio 2013. So first off, there are three parts in this tutorial. The first part is preparation, and there is a set of software. They are free software, and you need to download and install before we can get started. The software is in this list. The couple notes I want you to know about this software is first of all about GitHub. After you download, you can download GitHub for Windows, and it's free here. And you also need to create an account. If you not already have an account in GitHub, go ahead and create an account in GitHub, because all of my scripts that I use to for this purpose, I create a project in GitHub. So you need to create an account in GitHub in order to get to my project and to clone my project at your local machine. Another thing I want to note about this list is that when you download the Boost zip, the Boost source code, you need to download it in the zip format. You need to download in the zip format explicitly. Any other format will not work, so you have to download it as a zip format. Other than that, it will take some time for you to download and install the software. So this is a good time for you to go ahead and pause your video, and so once you download and install, you can continue the second part with this video. Hello everyone, I assume that you now have your video download and install, and you ready to get into the second part of the tutorial. Like I say, after you download the GitHub, you will have in GitHub, you have Git shell and GitHub, and I assume that you already signed in. So and I have the Git shell here as a shortcut on my desktop here. So I go into start Git shell, and also for this purpose, I create a folder in my F drive. It's called boots build underscore VS 2013, and in this folder I have another folder created. It's called downloads. In downloads, I already download my boots 158.zip file and then put it in this download folder. And so now I am going to navigate to that folder, and like I say, I create this project in GitHub. If you sign in to GitHub, you can look for my username Stephen Ong 2006, and then look for this project under my own repository. And also down here you can see, there is a clone URL. So I go ahead and copy it and I will issue the command git clone to the URL. So it's go ahead and clone my repository locally, and all the works that we are going to do is inside this. Notice that it create a project locally for me from the clone command, and all the works that we are going to do locally is from within this folder. So now, as you can see, the clone is done, and let's go into the folder, and there's files and folders. One folder called source, and in this folder it contains all the zip file that we're gonna need. The one zip file that we still going to need is this VS2013.zip. I go into copy it to the source folder. So now it's copied into the source folder. Now at this point we are ready to get started. So I go ahead and show you how to bring up the, let's see. Okay, so Visual Studio 2013. So if you install Visual Studio 2013, you will see this this set of the application in your in the Windows application. The one that we particularly interested is under under Visual Studio Tool. So we bring up the Visual Studio Tool. You will see the developer command prompt for VS 2013. I create a shortcut here, and I customize it to the way that I want it. So so I go ahead and I will invoke my command prompt from this shortcut. Now that I have the shortcut, I will navigate to that directory. We are going to use a tool called nmake. I think that's so. Okay, so nmake is a utility in Windows comparable to the make in Linux or Unix. Basically, nmake understand make file, and as you see, we have a set of these are the make file that we're gonna fit into nmake, and we're gonna fit this make file into nmake. I will explain about what the make file is, but for now, if you issue the command nmake /f make, hang on, 13. Oh, I need to go into the boot. Okay, so if I issue the command nmake and /f and make main and all, this command will then kick off the build process. Okay, and let's go ahead and run that command right now. And God, And as you can see right now, it will start extracting all the zip file that in the source folder, and by the end of this process, it will then kick off the build. In come with boot's source file, there is a build tool called B2, and it was first build B2 for the Windows environment, and then it built the rest from there. And something that worth noticing, let's wait until it's finished the extraction of the source file. As you can see, right now it's extracting the boot 158, which is into this, and is extracted into this folder. So wait for some time for it to extract. The reason why you have to I couldn't include this boot 158 is because it's too large. GitHub it's larger than the size that GitHub allow me to include it into the project, and that's why you need to download it separately and put in the source folder before you can start the build. So now it's extracting the build continually. And also we in a little bit later we will need to use another utility called tail to because during the build as you can see right here, this is the command that that is run for the bootstrap makefile, or and then it will redirect all the output into the boost build log. So as you can see right here, the boost build log was created as a result. So the purpose of that is if you run into any kind of problem during your build, you can then later on view the boost build log file. It's just a text file, but for now, in order to see what's going on, there's a command called tail, and that way you can view tail. Oh, tail dash F. Okay, so right now, this part Boost telling us that okay, I gonna try and build all of these libraries. Something notes worth noting that it will build the MPI since it found the MPI that we installed earlier, and also it will build Python, the boot interface to the C++ interface to the Python programming language, and the rest is just the library that is going to build. So if if you continue to see the, then it will tell you, okay, this is what's going on in there, and all these activity is recorded in the boost build log. Okay, it depending on the speed of your machine. On mine, it usually take like I don't know, 3, 4, 5 hours to finish the build, because it build there is it build the library in 8 flavors. Let me show you. So it will build the library will build in the following flavors: static and share. And for static, it will build static debug, release, and static 64 debugs and 64 release, and same thing with the share library. So it 8 flavor that it's building, and it takes some time. If you have just have an average computer, this might be a good time for you to take a break and go and come back later once it's finished. And then at that time, we will go through a process of how to go about testing the library within Visual Studio 2013. Okay, I'll see you back by then. Hello everyone, welcome back to the tutorial of how to create a Boost build environment in the window and to be used in Visual Studio 2013. I hope the build went well with you, and assuming that you now finish the build has finished in your machine. So as you notice, it's create this folder as a result, and within this folder there are 8 folders that containing the built libraries for the 8 flavors that we're talking about. And for that, and let's go into one of the folders just for the to take a look what's inside there. And for example, I pick boot static debug, and within this folder there's 2 folders called include and lib, and then underneath include there's a boot 158, and then there's a boot directory, and underneath that there's a whole bunch of folders and header files for these other for the Boost library of this particular flavor. And same thing, there are a whole bunch of .lib file. These are the built libraries of the Boost. Okay, and okay, so we're gonna pick this particular flavor and then do some testing with it. First off, let's go to the boost.org, this one, and if you this is the main page of the Boost libraries, and then you can go down to the libraries here, and for this particular testing, we're going to pick the ASIO. It stands for asynchronous IO, and this is the author of the library. And we will go into the examples, and we going to pick the C++11 examples. And for this particular testing, we going to pick the chat application. Okay, and in the chat application there are chat message, which is a header file, and a chat client, and a chat server, and here are the source code of each. So the chat message is a common header that being used by the client and the server. As you can see here, this is This one is the client, and it uses the chat message header, and so does the chat server. It also uses the same header file. We are going to create a project in Visual Studio 2013. This is my Visual Studio 2013, as you can see. Visual Studio 2013 here, and I'm gonna start it. Okay, so here is my Visual Studio 2013. I going to create a new project, and I go into create it under my Boost Build Visual Studio 2013. Select folder. I go into call it Boost Example ASIO chat, and it will be created under Boost Build underscore Visual Studio 2013, and I want it to create a directory for the solution. It is a console application, so I go click OK here, and I go into click Next. I don't want any pre-compile header. I don't want any security development. I only want the empty project. So I click Finish. Hang on. Let's go back. Hang on. Okay. Okay. So I go into select folders, and yes, okay. Next. I don't want pre-compile header. I only want okay. I think I want to rename this project to chat server, because that's what it is. Put example chat server. So the solution is ASIO. Well, I just call it rename it further and call it put example. Call this one is chat server. So the solution is boot example ASIO chat, and we have one project called chat server. And for simplicity, I go ahead and remove these two filter. I only use the source file, and first I go into create a new item, and this is a C++ file, and so that we can just copy the source code from here. And so I call it the same way that the website call it, and I say add. So it create an empty file for me, and I come over here. I just go ahead and copy the source code from here. Okay, come over here. I just paste it. Okay, and I save the chat server. I do the same thing with the header file. So I come here and I do add new items, and it's a header file. And so I come back to the website and copy first the file name, and I say add. So it create an empty file for me, and again I copy the whole text of the source code, copy and then paste and then save. So at this point I have all the source code that I need for this particular project. Oh, by the way, he's standing out, so I go ahead and move him in so he'd be together with the source file. And at this point I'm ready to configure my my project environment. Notice that we use in order to use the header and to use the library, we have to tell it where the library is. One place we need to tell it is where the include directory. So we need to point it to where we have all the header file is. So we say that we're going to use the boot static debug, and so we go into tell it to use the header files underneath the static debug. Okay, and notice that I stop here at the boot, and I show you in a little bit why. So we just select this folder and I click OK here and click apply here and click OK. So that takes care of the header file directory. The reason why we stop at the boost is because as you can see, the boost is always included as boost slash something something. So that's why we stop at the boost. That's the way that the all the boost is all the boost header file declared. And so we also need to tell it where our the library is. So we go into linker, and then I think it's in general, and then additional library directory. Okay, so we are going to do almost the same thing. We tell it where the library is. So and static debug lib. This is where the library is. So I say select folder and I say OK, hit apply, OK. So now we ready to compile the source code and see. So I'll hit OK. At this point we have a number of warning. This warning is saying that we need to tell it, okay, what kind of window environment that we're compiling, and it say, okay, you have to compile using this at least this version of the Windows XP or more in order for you to successfully operate in this environment. So I will go into property again, and then C++ preprocessor. I'm gonna add that directive in here. So just like the way that it's recommended. So I say apply, okay, and then we come over here and then we try to rebuild. So we took care of that warning. Now this warning is particularly about some code in the standard C++ library, in particular string cast and sprintf. These are threads. These are the thread safe version of the string cast. We're not gonna do anything about that in at this point. You're welcome to find out why is thread safe and why is not safe. But for our own purpose, we just go ahead and suppress the warning. This is not a good practice in if you are doing some serious work, but just for our testing purposes, we it's suffice for us just to suppress the warning at this point. So I go into tell it, okay, don't worry about a warning. We know what we're doing, so that's what we do, and then we compile again. And so at this point we successfully compile and no warning. And so I will, since we need two executable, one for the client and one for the server, we need two projects. I'm going to create another project here, project, and I call it chess client, and it's a window console application, and I click OK, I click next, and I don't want any pre-compile header, I don't want any security, I only want an empty project, so I click finish. So the chess client project is created, and same thing, just for simplicity, I don't want any header file filter, and I don't want any resource file filter, so I just remove those. And so now I can add so I go ahead and remove these two so it won't be confused. So I go into add new items, and it's a C++ file, and this is a chat client.cpp, so I'm gonna tell it that this should be called chess_client.cpp, and I'm gonna add it. So it create an empty file for me. I go ahead and highlight it, and copy the source code, paste it, save it, and I am going to do the same thing with the header file. Chat message, oh, it's a header file. And I go into edit. Okay, chat message, and I'm going to copy the content, paste it, and save it. So now I'm ready to build chat client. Okay, so it says cannot find boost ASIO. So now we need to go through the same configuration. First of all, we need to tell it where is the ASIO include file, header file is. So we're going to do the same thing here. We're going into Visual Studio, static debug, include boots, and then select folder. And since we are here, we're going to tell it where the library is also. So additional library directory. Okay. Debug lib. Okay. So here we go. And now we ready to recompile chess client. And the same thing. We need to add these preprocessor directive into our project. C++ preprocessor. Edit. Oh. Okay. It won't let me go into that. Okay. Will let me go. Okay. Okay, we say that the same thing. We say that we know what we're doing here. Okay, apply. Okay. So now we get ready to compile again. Okay, and here we go. We compile successfully, and the executable is under boots example ASIO chat debug. Okay, so we could just go ahead and copy the path here. So for this, because this is a network program, we in order for, if you have firewall configure on your Windows, then you need to allow some specific port for it to work. Okay, I'm gonna pause my video a little bit, and then I just so that I open a port, and then I'm gonna resume it. Okay. Okay, I'm back now. I have opened a port for this purpose. Now we need 3 command prompt windows in order for us to test the chat application out. The reason why we need 3 command prompt is we need one for the server, and one for the server, and 2 for the 2 clients that it can talk to one another. And let's go to where chat debug. Okay, this is where the client and the server program is. So we're gonna all go there. Okay. I need one more window. Okay, so to start with, we need to start a server, and the server need at this point I don't know what the server need beside the application name. So I just saw the server. Okay, so it say if you want to run the server, you need to give it a specific port. So I run the server, and I already opened this port for the server. So same thing. Chat client. I don't know what the client wants yet. So okay. So the client wants beside the besides itself, it need to have the host and the port. So I just let it connect to local host, and to port 5555, and same thing on another Windows. Okay, so I'm gonna intend to say hi, how thing going. Okay, so I send the text, hi, how's thing going, to whoever want to listen to it, and sure enough the text gets here. How about I am well, how are you, how are you? Okay, so the text, as we can see, the text get through okay. That means that our program linked with the library okay, and it's functioning okay. And so that show that our library, the library that we built, actually working. And so this concluded the tutorial, and in my opinion, if anyone want to seriously programming in C++, that person should learn about the Boost library and how to use them. It's a very, very powerful set of the libraries that it can become a very, very handy, very, very good tool set. Okay, and I hope this will spark an interest in you into learning the Boost library. Okay, and I hope you enjoy, and I hope you learn and excel in your C++ programming. Okay, and see you around. All right, you have a good one. Bye.